Let's do a solution walkthrough to the APList problem. I have not programmed it yet. I'm doing it right now. I usually like to start with my test cases, so I haven't even made an APList class. You'll notice I've just got main. So let's imagine that it exists. So APList, I'm going to call it list equals new APList. I'm going to create it with a relatively small initial capacity because that's going to make it easy for me to test, to make sure that it doesn't go out of bounds and stuff like that. So let's do this. Let's loop, like 10 times, and let's say list.add a. So I'm going to see what happens if I try and add too many things to the list. Let's do list.add b at index 0. So that'll test to see whether I can insert b at the beginning. Let's do list.remove. Let's do list.add c at list.capacity -1. So list.capacity, let's do list.size -1. Because list.size is going to tell me how many things are already in my list. And so this is going to be so this is going to overwrite whatever the last thing in my list is, basically. I'm saying let's add it there. Except it's not going to overwrite it. Really, I'm going to try and shift it. And what else do I want to do? Maybe that's enough for the moment. Okay, so let's go ahead and create it. I'm going to create APList right here. It's going to have a string array called data. I'm going to have an int called next, which is going to point at next free index in data. I'm going to create my constructor. So data equals new string max, and then next is 0. Let's create all my methods. So I know I need capacity, and that's actually one I can return right away. That's just going to be data.length. Public int size is how many things have I saved in my list, and that's the same as next. Because think, if next is 0, that means the next free location in my array is 0, but it also means that I haven't stored anything. So its size is going to be 0. As soon as I add something, next is going to point at the next free location, which will be 1. But that also means that there's one thing that has been saved before it. And so if I ask what the size is, I want to return 1. So you can also think about this as how many elements have been stored already. Let's see what else we need. Okay, so I will need, I will need void add string value, and that's going to add to the end of the list. Let's make add value int index. That will insert it at an index. Let's make get index. So you'll notice that what I'm doing is I'm making all the methods signatures. These are sometimes called method stubs, just so that my API is set. Like what the set of things that I'm going to do is set. But I'm not actually providing any implementations yet. So public void remove string value. Public string remove int index. Or let's return null, I guess. Okay, so let's see. I got add, I got get. Oh, I missed contains. Let's do, and then I have size and capacity. Okay, so that's the complete set of methods I need. I'm going to go through and implement the easiest ones first. So contains, I can definitely do. I'm going to use a for each loop. So I'm going to loop through all of the data, and I'm going to say if value equals val. Oh, you know what? I'm actually not going to do this because this is going to loop through a bunch of null values. Really, I only want to loop up to the size of my own list. So let's do this actually. This dot size And then I'm going to say if value equals data I, then return true, otherwise return false. Okay, so again, the reason I did this, so this dot size doesn't loop all the way to the end of my capacity. Like if I created a length 1000 array, I wouldn't want to loop through 1000 elements if I'd only added 2 things so far. So this just loops through the indices up to what I've added so far. All right, so far so good. Let's do add, because this one should be relatively straightforward. What I want to do is I want to say data.next equals value, and then next plus plus. And that's great, except that I also need to double check that I'm not going off the end of my array. So I only want to do this if next is less than or equal to this dot capacity. Do I want to do it if it's equal to capacity? No, I don't think so. Less than capacity. Because if capacity is 1,000 things, then that means the last index is 999. So I'd want to make sure that my next index is less than 1,000, because that's off the array. Okay, so far so good. Let's do this. So let's add at a particular index. So first I'm going to check if my index is in bounds. And I guess we might as well write that right now. So return if index is greater than or equal to 0 and index is less than this dot capacity. Well, this is a good question, actually. Let's think about this. So there's sort of 2 different ideas. One is it within the capacity of my, like, is it within the defined indices for my array? But separately, like, let's say I have an array that's length 1000, but I try and add immediately at index 500, but I haven't actually added anything yet. Like, do we want to let ourselves add a value that's directly in the middle of the array? And I think the answer is probably no. So let's think about what we want here. So I think actually I'm going to delete is in bounds, because I think the name ambiguity is going to make this more complicated, or it's going to make it kind of less clear than it could be. So I want to say if index is greater than or equal to 0 and index is less than this dot size, but also equal. Because if it's less than this dot size, that means I'm inserting something. If it equals this dot size, that means I'm placing it at the end of my list. So nothing else needs to be shifted. But I think that should still be okay. Like if I have a list that contains one thing, the next free index is 1. So I should be able to say add something at that very next index 1. Okay, so this is saying kind of, is it in range? So the first thing that I want to do is shift right from index, because I want to insert things. I want to insert value right at index. So I want to first shift everything starting at index to the right. So I'm going to make a helper method for that. And then once everything's been shifted, then I can say data at index is going to equal value. Okay, so let's write the helper method. So now I want to loop this dot size minus 1, and then I is larger than index, and then I minus minus. So I want to start at the last element where I've assigned something, and I want to loop backwards. And what I want to do is I want to take the element that's to the left of my current location, so that's I minus 1, and I want to save that element to the right. So let's imagine this. I is pointed at the very last thing in my list, the last value I've saved. I want to start one to the left of there and copy it to the right, which goes over top of size. Except this is tricky because I don't actually want to overwrite the last thing. I actually want to shift it. So let's do this. Let's say I'm starting one. So let's say I'm going to start at next because that's the next free location. And I want to copy the thing to the left of next into next. So that's going to shift to the right. And I want to keep looping and do that all the way until I get to index. So the last time through the loop, I is going to equal index, and I'm going to shift index. Oh no, I don't want that. I want to stop I one larger than index because I'm going to reach to the left to get index and copy it into the element directly to its own right. Okay, a little bit tricky. And then because we shifted right, we need to add one to next there. And now the only thing we have to check is to make sure that we're not going to go out of bounds. So hold on. So I guess let's just add a check here. We'll say if I equals capacity. So if I does not equal capacity. Because if next is, because if our whole list is full and next is pointing off the end of the array, then I know that I don't actually want to run this line of code because it's going to try and assign something past the end of the array. All right, so I think that's done it. Oh, you know, we should be testing as we go. Sometimes, sometimes I forget my good practices. Let's do get. So in this case, we'll say if index is larger than or equal to 0 and index is less than this dot size. So that means if it's within the range of defined values, then I'm going to return data index. Otherwise, I'm going to return null as a way of indicating that they requested an index that's not defined. I mean, I guess another thing we could do is trigger an index out of bounds exception, but I don't want to show you how to do that right now. Okay, remove. So remove value. So I think the first thing I want to do is find the value. So let's say, let's start at the beginning and let's loop up to this dot size, and we'll say if value equals data I, then that's the one that we want to remove. And so I'm going to say shift left from I plus 1. And what that's going to do is it's going to take the value at I plus 1 and shift it left to overwrite the value of I. And then after we've done that, we can safely return because we don't want to keep going. And we're not going to try and remove all of the values. We're just going to try and remove the first one that we find. So let's write shift left from. So similar idea here. Let's loop. Let's think about our loop bounds in just a second. But what we want to do is, like, from a given place inside our array, I want to take the thing on the right and like copy it left. So I'm going to take the thing at array I and assign it to I minus 1. So that's going to copy things left. Okay, so where do I want to start? I think I want to start at index because here, the way that I'm using it is we're going to supply it the index that's 1 to the right of the place that we want to overwrite. So if I start there, I'm going to start by taking that value and copying it to the left. And then we're just going to move one by one to the right until we get to the end. And we only have to go up to this dot size. Okay, except our array is called data. And then at the very end, I want to take next and decrement it. because we've essentially removed something from the middle, and so now our array contains one fewer things. Okay, that seems pretty good. What am I missing? I think that looks like, oh, remove at index. Okay, great. So remove at index, we can actually just immediately run this one. Shift left from index +1. And, oh, before we do that though, we have to save the thing that we're going to overwrite. So let's do data index, and then after we overwrite it, then we'll return it at the end. And then we don't want to do this if the index that we're asking for is out of bounds. So if index is less than 0, or index is bigger than or equal to this dot size, that means it's out of bounds, and I'll return null as a way of indicating that it's out of bounds. All right, so let's test it out here. You know what I think I'm going to do? I think I'm going to add a toString so that it's easy to look at. So sout_list. Let's do this here. So here at the bottom, public string toString. And I think what I want is, so I'm not going to do this in a very efficient way, but let's loop from 0 up to this dot size. And I guess I'm going to display the elements separated by commas inside brackets. So let's do this. Out plus equals data I plus comma space, and then at the end, well, you guys don't know about the, well, that's fine. We'll oh, you do know about substring. Okay, so this is going to display an extra comma space at the end that I don't want. So now I'm going to remove the comma space by saying out equals out.substring, starting at 0 and going up to length minus 2. So if you don't remember about substring, this isn't a big deal. I'm just saying, like, start at index 0 and end at the index where the last comma is, which isn't going to include the last comma. So this is just going to, like, basically cut out the last comma space. And now I'm going to append that thing, and then I'll return out. Okay. So let's test this one step at a time. I want to see what it looks like as I add a bunch of A's. Cool. That's going to be my toString, huh? What am I missing here? Right, so if out.length is bigger than 2, and let's do this. Okay. Cool, so I can see it starts empty and I'm adding A's one at a time until it reaches 5, but I don't go out of bounds as I'm continuing to add more 5s. Let's try adding B at 0, and let's try adding like C at like 3. And then I'm going to comment that out. Oh, we need to display it, I guess. Cool, getting out of bounds already. That's pretty normal though. It's in shift right from. Okay, so where's that happening? Oh, that makes sense. So think about it. My array is completely full. So next is actually pointing off the edge of my array. And I'm saying, let's start there. Oh, except that should be catching it. So what's happening here? Let's print out capacity to make sure that capacity makes sense. Oh, this is a great example to do. Oh, I should teach you guys a debugging lesson. So I'm going to add a breakpoint right here, and I'm going to run it again in debug mode. Okay, so that looks like, all right, so next is 5, and I've got elements up to there. So I is 5. Okay, so we skipped that. That makes sense. So now I is 4. So we're going to do... Okay, so it's like we're copying things, so that's working. So maybe that's not the problem. Oh, but then I added to the capacity. Aha, that's the problem. Okay, so I was actually doing this check correctly, but I don't actually want to do this unless... So let's do this. If next is bigger than this dot... What am I trying to say here? Capacity plus 1, then... So basically, so this is sort of like a cheap hack. Or let's do this. So let's say next equals math.max, or sorry, math.min of next plus 1 or this dot capacity. So it's like I'm going to either add 1 or I'm going to set it to the capacity, whichever one is smaller. So that makes sure that I keep adding 1 up until I get to the capacity, but then if I reach the capacity, I'm not going to keep adding 1. Okay, that seems nice. Yay. Okay, so here I've successfully inserted B and the A is shifted down. Here I've got C. Let's insert one more thing at the beginning and see if the B and the C shift in the way that we expect them to. So let's add D at index 0 and then print out list again. Great. Let's print out size and capacity. Yikes. Wait, what? Oh, sorry. List.capacity, okay. All right, so 1 out of 5, 2 out of 5, 3 out of 4. Okay, so that makes sense. What have I not done? Let's test remove. So I'm going to say list.remove. Let's remove A, which should remove the first instance of A. And then let's remove A again, which should remove the next occurrence of A. And then let's remove whatever's at index 3. And then let's say removed, and then val, and then let's display the list again. All right. Cool, so here we removed, so there's, okay, so there we insert B, there we insert C. Here we insert D, and B shifts and C shifts, that's good. So now we're removing the first occurrence of A, which is here, and A and C have shifted. Now we're removing the second occurrence of A, which is good. Then I said remove the thing at index 3, which doesn't exist, because that's off the edge, so that looks okay. Let's try and remove the thing at index 0 and make sure that works. Okay, so here we removed D and we get BC. Okay, so this is looking good. I'm feeling pretty good about this. All right, I hope this was helpful.